Before we ship an agent, I don't want it felt good in the demo. I want proof. Agents don't just answer, they plan, they call tools, they branch and remember things. A tiny tweak in wording or a model update can quietly change the path they take. That is why we evaluate. So in short, evaluation turns a great looking prototype into reliable software you can trust release after release. So here we are going to implement an evaluation suite to evaluate our airline agentic solution repeatedly. Okay, so in this cell, we are defining our offline evaluator. It's run in few labeled scenarios and tells us in seconds whether the routing is happening properly, tool usage is happening properly, and the guardrails are working properly or not. We install the Nest Async IO. So the colab can happily run async code, nothing else to configure. Then we'll be importing some needed libraries. Now, this part is very important. Here we are actually making sure that these agents are existing before we run any cases, and we are also ensuring that the airline agent context is also defined and configured properly. Then we are going to define the path where we are going to place our eval test cases. So our test cases are available as a JSON document. So here we have these 4 cases defined, which has the ID, then the user question, and then the intent. Based on this intent, which agent is expected that this intent or the user query to be routed, and which tool to be called by that agent. So these are the test cases defined like this. Now, in the second test case, we are having a scenario for seat change. So the user query is about, please move me to seat 7C. My confirmation number is this. Then here the intent to be recognized as seat change, and the triage agent should route this call to the seat booking agent, and the seat booking agent should call this tool, which is update seat. And similarly for other test scenarios, for example, the third test scenario, which is about the cancellation. So for cancellation, again, there is this user query. So the intent to be recognized as the cancel, and the triage agent to route this call to the cancellation and the rescheduling agent. Similarly, we have the fourth scenario. So we have defined our test cases or the test scenario in this JSON document, and of course, this can be loaded offline, but here just for a demo purpose, is a small evaluator. We are just dumping that into our current directory and then reading it from there. All right, so this is our evaluation harness, the piece that turns the demo into something we can trust. So we start by importing the agent SDK. So, the piece we want to observe, like the message output, hands off, tool calls, and the tool outputs. So we import them. Now we defined some helper function. The first helper function is the load case. This just reads a JSON file, one text per line, into a Python list. Each case contains the user prompt and what we expect to happen, which agent should own the turn, and which tool must be called or avoided, and so on. Next, we have another helper function, which is save tool name from item. So the tool call events come in a few shapes depending on the backend. So this function is a universal extractor. It tries the direct attributes like tool name, function name, then looks inside a nested tool object, and finally falls back to the raw OpenAI payload to pull the function name. If it still can't find it, we label it just tool, because if it is not able to find anything, then we just label it as tool. Otherwise, we return the corresponding tool name. The third helper function we have is the collect events. It walks over the SDK's new items from a run and collects four things: the tool calls, the tool outputs, the final texts, and handoffs. So this gives us a compact summary of what happened for a single run. So that is the purpose of this collect event function. Then we have another helper function called contains any. Is a tiny string helper we will use for checks like did the assistant ask clarifying questions. We don't need full-blown NLP here, just presence of a few keywords. So that is why we have just defined a lightweight function. And finally, we have the core, which is the eval case. We take one test case and run exactly one agent turn through runner.run. So one test case and one run at a time, starting at the triage agent with a fresh airline agent context. Then we parse the run into the events and capture the last agent, the specialist who ended up in the control after handoffs. We form called names from the tool calls we saw. There is a neat extra. If our tools log self into context.tool log, we merge these names in, preserving order and uniqueness. That covers the backends that hide tool names and tools that do, meta work. Then we combine the tool names from the run items plus the context tool log. And then we do those checks individually. The first one is the routing check, where we compare the last agent which was called, and then we compare that agent with the expected agent from the test case. And if the last agent and the expected agents are same, then it is the kind of a test case pass, or else it is fail. Similarly, for the tool usage check, we will compare, in the tool name, if the called tool name is same as the expected tool. If that is the case, then the test case pass, else the test case fails. And similarly, if in a certain test case, if the clarification question is supposed to be asked, then this will check if the respected question were asked or not. And accordingly, the test case will be marked as pass or the fail. And then if there was any confirmation expected, then there is a test case to check if the confirmation was collected from the user or not. And accordingly, that test case will be updated with the pass or the fail. And finally, it is going to return the test case ID, whether it is passed, failed, the last agent, the last tool calls, if there is any handoffs, and the reason. Now, this run eval loops over all cases, prints one-line status per test, like the pass or the fail with agents and the tool, and then prints a scorecard. And finally, we'll compute the percentage. So if we execute this evaluation for the defined test cases on our agentic solution, there were, I think, 4 test cases defined, and it is running one after other. And first test case pass, second test case also pass, third test is also passed, and the fourth one also passed. So the total pass percentage is 100%. And if you see the results, so for the first test case, the expected agent was FAQ agent, and because the agent use is also FAQ agent, and therefore this test case was marked as pass, and the tool was supposed to be FAQ lookup tool, and the tool call is also matching, and therefore this test case was marked as passed. Similarly, for all other test cases, the agent, the tool, those conditions were evaluated, and it was matching with the defined test case, and therefore all these 4 cases are passed. This is how you define and design your evaluation framework to evaluate your agentic AI solutions.
This video is part of my course Mastering AI Agent using OpenAI Agent SDK, the course which I have published on Udemy. The link of that course is available in the description. So if you are interested, please follow the link and get your certification done.